Hello, dear authors and invited guests. Welcome to Technical Session 2C. Myself, Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all to the 7th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2022 through Zoom. I hope you will all enjoy the knowledgeable and interactive session. And in this session, we have eight presentation and eight presentation, and each presentation will be given 8 minutes for the presentation and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder to conclude your presentation. There's one special note for the presenters that you may all please stay connected with us till the closing remarks. And if you have any query or any suggestion, you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for the session, Professor Vijay Singh Rathore. Professor Vijay Singh Rathore is the director of Sri Kekarni University College, Jaipur, India. Presently, he is working as a professor of CS and director international at IIS, deemed to be University, Jaipur, and secretary of ACM Jaipur chapter and past chairman of CSI Jaipur chapter. He is having a teaching experience of 20 plus years. His core research areas include internet security, cloud computing, big data, and IoT. He has organized and participated 25 plus national and international conferences of repute. Thank you, sir, for your valuable presence.
I welcome all the participants, and I think we should start the session now.
Yes, sir. I would like to invite our first presenter, Ashish Kumar, and he's presenting a fake news classification and identification model based on machine learning approach. Dear author, you may please start your presentation.
Good evening, session chairs. This is myself, Ashish Kumar. I'm presenting my paper, a fake news classification and identification model based on machine learning approach. We are 3 faculty members who have authored this paper. This is the table of content, the introduction, objectives, contributions, data set that we have taken to analyze over the various classification algorithm and feature engineering we have done. We have inferred some of the features of data set. Then we have calculated some metrics, finally the results and the conclusion and the references that we have gone through. So this is about the fake news analysis that we want to get into. We want to have an insight, since nowadays social networking and the media platforms have grown at an unforeseeable rate, and it has enormously increased manifold. What has because of the social contribution, the data which is being produced by these websites have also increased manifold, which are actually now being utilized to divert the psychology of the people who are being actually consuming these information. So that means now that this has become an important part, that you can drive the users, you can divert their mind, like it's being you have seen that during the political phases, a lot of messages starts coming which are actually inclined towards which have got their own interest, again intendedly being circulated over to media platforms, WhatsApp, Facebook, Instagram, in order to divert the psychology. Okay, so that plays an important role. So we need actually it leads to a generation need of a communication or a identification system which can clearly distinguish between the false and the real news. Okay. So these are the objectives. Objective is to first is to identify and classify the fake news by using the LSTM. And means we have taken these algorithms: LSTM, PAG, passive aggressive classifier, naive Bayes, logistic regression, SVM, support vector machine, BERT, and the random forest. Then we have obviously evaluated the performance of these models onto the considered data set. And then this was being compared. The computer. No. This is the contribution. No. This we have taken the ISOT dataset, which is having two files, true.csv and the false.csv, and there are total 44,898 samples are there, out of which 21,417 samples are true and 23,481 samples are false into the false. We have got the 5 attributes pertaining to these samples: the title, the description of the news, the subject, and the date, and the label, whether it's a true or a false category kind of. What we have done, we have taken these standard steps, imported the libraries, the data set, and then check the correct and the missing values, and then divide the data set into the test set and the training, considering the 70 versus the 30. 70% part was taken for the training and the 30% was taken for the test. Then during the feature engineering, what we have seen, observed into the data set, that there are average number of characters in the real news are approximately 64, but in case of the fake news is 94. That means the fake news are having more number of characters. This is a kind of inference was being drawn. Then the average number of unique words and real news is 9, but in case of the fake news is 14. So that means the unique words are more in case of the fake news. Special characters are more in fake news compared to real news. So that means intentionally, since they have created those news, so they have induced more number of unique and special characters. This thing. Then we have calculated these 4 metrics: the accuracy, the precision, and the recall, and the F1 score. Accuracy is actually to identify the number of correct predictions over all predictions, which is like true positive plus true negative divided by the all all the matrices, true positive, true negative, false positive, false negative taken together. Then we have calculate the precision, that how many positive predictions made are correct. That's true positive divided by the true positive plus false positive. Then we have taken the recall, that how many positive cases the classifier correctly predicted over all the predicted cases in the data. It is also referred to as the sensitivity, and we have calculated the F1 score. These were the results that we have drawn after calculating this. And the left side figure in blue, green, and red colored is having 3 metrics: precision, recall, and F1 score. Overall, the considered classification algorithm PAC, first one is the PAC, second is naive Bayes, logistic regression, BERT, LSTM, SVM, and random forest. And their values have also been depicted over to the figure. Then the highest, if you see, the highest performing models are the SVM and the random forest in case of, if we see the precision, and near to that is the PAC. And if you see the right side figure is having the accuracy of these said algorithms. In terms of the accuracy, the PAC and the SVM has more or less, even the PAC has outperformed the performance in terms of the SVM. Okay, so that is what we have put into the abstract also, and that the PAC is outperforming the SVM while considering this data set. Now, during the investigation, there was one more. We have taken the approach towards the generalization. Since this data set was more tuned towards the political news, okay, not was a general kind of data in nature. That means not having the data pertaining to the other field, like sports, or to the television industry, or to the educational institute, since the fake news are of different covering the different kind of subjects. So in that case, while we were checking the news from the other field, the performance was not the same as it was showing for this present data set. So in order to do that, we'll have to have a wide data set which is covering like wider range of topics. So that was a kind of like limitation of the work that we have proposed. So in future we are going to consider the different other algorithms or classifiers which have been proposed in the literature, and will be applying this the considered classifier onto the like wide variety of news data set, which covers approximately. So that was a kind of limitation to this job that we have. And then these are the references that we have considered, and I have put the few references, not all. I have considered the few like the recent references. That's all. Thank you.
Vijay sir, any question for the presenter?
Yes, I'll ask a question. What would you say was the hardest thing or the greatest takeaway from this experiment?
Like what I said is that this work is actually not generalized. It needs to be applied over to the general category of section, that we can consider the news from all, since while we are applying some identification system which can clearly identify whether it's a false and real, that time the subject should not be considered actually, that our system can only identify the political kind of news or a sports category kind of news, or a like, okay, so that actually thing should be also the length of that news article, that also varies. So there were certain limitations that were seen. So in order, then what was limiting us to do the job is that we were not able to find out some existing data set. Okay, so we'll have to actually devise a new data set in order to do that we have actually.
Okay, thank you.
Thank you, sir. Thank you.
Thank you, sir, for your great presentation. Now, I would like to invite our next presenter, Rohit Rastogi, and he's presenting on a statistical analysis of the contribution of enrollment process towards the quality of higher education in the state of Uttarakhand.
Yeah,
The
good
presenter,
evening.
you may please start your presentation.
Yeah. Good evening, the Honorable Chair, Session Chair, and all the panel members, and presented everyone. So is my screen is visible?
Not, sir, still not, it's not shared.
So till the time we can just continue with the next candidate, let me just rectify this technical glitch.
Okay, no worries, sir. We'll start our, we move forward to our next presenter. Our next presenter is Sonithoi, and she is presenting on an empirical analysis of different classifiers on COVID-19 vaccination data.
Good afternoon, sir. Am I audible?
Yes, ma'am, you are audible.
Good afternoon, sir. Today, I, Sonithoi Ningombong from Assam University, would like to present a paper presentation on the topic of empirical analysis on different classifiers on COVID-19 vaccination data. So should I start my presentation, sir?
Yes, ma'am, you are.
Yes.
So the title of my paper is An Empirical Analysis of Different Classifiers on COVID-19 Vaccination Data. And here are the outlines of my presentation. Introduction, objective, system design, like what the Twitter collection, data pre-processing, polarity evaluation, feature extraction, document representation, machine learning, and performance evaluation metrics, results, conclusion, and references. So during the time of this COVID-19 period, where we all are in security and we can and again, India is also one of the most affected countries and suffer. So I have collected the tweets from our Indian, and I have done this machine learning classifiers on that. So for this, these are the objectives of my presentation. The core objective of my paper is to visualize the sentiment score of Indian tweets users to identify the most influential positive, negative ideas about COVID-19 vaccination. And to achieve this, I did a comparative studies of Twitter data set with the existing models and analyze the outcomes. For the objectives, first I have collected the tweet from Twitter API, and then after that, on that collected data, I did this classifiers and then compare the performance of the various classifiers of the tweet. And these are the system designs for my these are the system designs for my work. First, I have collected the tweets. There are only few tweets that I have collected. It's only 20,629 tweets regarding the COVID-19 for the period of March, April 2021. And after the collection, I did this data pre-processing, but data pre-processing is also an essential trial to clean the raw text, because we can't do the directly twist for the sentiment analysis and all. After that, I did this polarity evaluation. For this polarity evaluation, I use the text block only to calculate the subjectivity and polarity of the tweets. And after that, I did this feature extraction. For this feature extraction, I use bank of words. And after that, document representation. For this purpose, I use this term frequency and the term frequency inverse frequency TDF, IDF only. And after that, I did the machine learning classifiers, like only 5 classifiers I'm using: support vector matching, naive, logistic regression, decision tree, and KNN. And in addition to that, I just did this BERT model also. And this is the polarity scores that I have done for my experiment, for my work. And this is the distribution of the sentiments for my work. And this is representing the number of positive and negative and neutral sentiments. And these are the word cloud representations of the tweets. And for the performance evaluation, I performed this accuracy, precision, recall, and F1 score. And for the results, and for that, after I have collected the data of around 26,000 something, but after the pre-processing, I could get a chip only 14,509 only. After that, the data is divided into 3 categories with the help of this text block: positive, negative, and neutral, with their polarity score. Actually, this polarity scores is rise from -1 to 1. -1 represents the negative, and the 1 represents the positive, and the neutral represents the 0 score. And as I have already shown in the figure also, these are the tweets for the neutral, positive, and negative polarity. And after that, I did data training and testing performance using the machine learning classifiers. For this, I have done 25% for the original data set for testing and 75% for modeling. For testing, I have chosen only 3,628 tweets out of this 14,509. And these are the my outcomes for these machine learning classifiers using the count vectorization. And according to this, support SBM classifiers outperforms compared to all other classifiers. And in this classifiers, the KNN classifiers is except the KNN classifiers, all are performing as good. And this is the performance using the TF idea vectorization. In this also, I got the support vector machines got the high accuracy compared to other classifier. And at here also, KNN gives the worst performance among all the regions. And again, and I have added the BERT sentiment analysis, but using BERT, I performed this analysis, and according to my experiment, BERT experiments give the approximately accuracy of 98 accuracy and 97% of average and F1 score. So it is the best performance. BERT gives the best performance. And here are the conclusions. So according to my work, I did a comparison of these machine classifiers only, and where over is represent for this TF and give the performance. Then TF idea, because I took only the few data like that for that only. So other future researchers can compare for this by taking more data and all. And according my work, BERT is the higher than any other all models. So according to my research, I got the positive sentiment is higher and followed by neutral, and very few of them were giving the negative sentiments. And these are the references. Thank you, sir.
Okay. There's any question for the presenter?
Hello, am I audible?
Yes, sir. Yes, you are audible.
Yeah, your paper was quite interesting, very nice. You told that your accuracy is 98%.
Yes, sir.
Is it so?
Yes, sir.
Yeah. So have you compared your results with the existing research? Any other research?
Yes, sir. That part I have not mentioned it yet, but I have compared with the deep learning like CNN and all.
Okay, so in compared to that research, like how your research comes, like it is better, or what do you feel?
It's better. In that research work, they got only 95 or 94 like that. But
Okay. And your accuracy is 98%. So
sure.
what is the main reason behind that?
Behind that, BERT classifier, BERT is more what to say.
BERT classifier. Okay,
Yeah.
fine.
Okay, sir.
Okay, nice. Thank you so much.
Thank you, sir.
Congratulations.
Thank you for your great presentation. And
Now we can
Now-
invite the next presentation.
yes, sir. Our next presenter is Rohit, and he's presenting on statistical analysis of the contribution of enrollment process towards quality of higher education in the state of Uttarakhand.
Good evening, sir. Is my screen is visible, sir?
Yes, sir, it is visible.
Okay, sir. Good evening to Honorable Session Chair and the co-host, Dr. Vijay, sir. So my topic is where I'm presenting a paper. It's more crucial to higher education. It's a statistical analysis of contribution of enrollment towards the quality of higher education in the state of Uttarakhand. As we know today, we are sitting with 1100 plus universities in all India and 40,000 colleges across India. So that's why I particularly focus on Uttarakhand, because Uttarakhand has become one of the prominent destination for a student to come and join for the higher education of the courses. So like how I find this problem. So it's problem which we find is that there is a very high competition among the private universities specifically for attracting a student in any of the pattern. So they don't want to highlight themselves in any of the context, like this is something a right university with different kind of rankings, different kind of agencies who claim that these are different, the best universities in North India, all India. So the concern about the entire thing is the enrollment process, because that plays a very important role in defining the entire trajectory of an institution, like how the institution go ahead from a 0 to 100 or 100 to come back to a mediocre institution. So that's why, but if you talk about a complete higher education, then it's just not only a one factor, because then the enrollment plays an important role, then faculty, research, academic infrastructure. So the motivation comes because there is a huge demand in terms of universities in hilly regions as well as in like the state. But if you see Uttarakhand as a demographically, like 70% is hills. And if you see out of 37 universities, 18 universities come up in just a vicinity of 60 kilometers, that is of Dehradun as a temporary capital, where you have lots of universities opened up. So in this paper, I just want to prove statically that enrollment plays a very important role, where the factors come up like enrollment policies, process, financials like fees, a scholarship, with the welfare scheme, facilities like infrastructure, industry academy relation, and placements. So this is one of the researches which I go with my literature review. So I find it out that this is a higher education institution quality assessment model, where like how each component plays a very important role, like its vision and mission and the reliability of the higher education institution, admission and enrollment division, administration and governance, quality administration and assessment, research, consultancy and extensions, teacher learning and evaluation, because that plays a very important role, how you bridge between a enrollment to a placement part. Then curricular attributes, student support services, the resource infrastructure, which is nowadays, it's like act as a passport, that's a mandatory requirement. Then it's about human resource management development, how you take your institution at a higher level. So sir, these are my literature reviews. So I went through with the recent and the old as well. So where I find it out, like Dr. Ahmed Sadiq said very clearly that one of the prominent researchers say that to achieve a higher standard of education, we need to apply a specific rules and advanced technology with good learning outcomes. Because today, if you go to any NEC or any of the rating agency, they always look forward for a outcome-based education. Then if I go with another researcher in 2017, he said this higher education model, which I showed over there, but again, he compromises like this is not the only model, like we can enhance as per the requirement, how the situation, how the things are going ahead. Then if I look forward for the quality control, that is the process in higher education benchmarking, because today every institution say that I am the best in terms of any kind of a rating, but like, is that the only parameter, or there can be any other change can be available? So there I want to look forward like this. So there is an objective that it's required a service quality in higher education, and it's required a grading of each and every area. So so in this paper, I purposely picked only enrollment as one of the factor, like how the enrollment, like if you see any of the universities, enrollment plays important role, where even the student take decision on the basis like how many students are enrolled, or what is the selection criteria, what is the admission kind of a process. That is something how it defined. So in my research, in this paper, I look forward for 8 private universities. So purposely, we are not disclosing the name of the universities over here, out of which 3 is NEC accredited, which is recently accredited. And 2 are the young universities, which is open just 2 years back. 3 universities are in this survey are 10 years old and yet to be aggregated. So there are 8 universities on which I run my questionnaire. So I picked up 24 items in each questionnaire and shared with 25 students. That is a data set from each university. The total, I got a data set of 200 students, where my questionnaires follows, like very specifically I asked, that's a closed question, that is openness and fairness in admission policies, quality of counseling and guidance provided during the admission process, equity, quality of admission process, and specifically the centralized admission process and the reporting procedure also. Then conduction of entrance examination, national level or a state level. Then transparency in evaluation system of entrance examination, exposure to international student, procedures and guidelines related to admission of international student, merit-based admissions, availability of program fee, facility available and faculty details, ICT during the admission process, because that is something which is an important part, like how you are connecting the student from a lead generation till to a end conversion of admission. Then financial support for any backward classes, any scholarship and policy and guidelines which is laid by the institution. merit-based scholarship percentages versus fee paid by the student, innovative scholarship for meritorious student, unique welfare scheme for underprivileged student, regional parity, because like if you talk about a state private university, then there is a norm that they need to give at least minimum 25% of a quota to a state domicile. Then admission policy for corporates, employees, especially part-time. Then facilitating for campus visit and tour during the admission process. What is the ease of documentation they help out in terms of hard copy of academic documentation during the admission process? The special support during the admission process for differently abled student, teaching faculty involvement in admission process, because this is something which is important, because now the people hiring a core marketing team which is not related with like teaching, they just only want to go a number figure. So like, is there any these kind of involvements? Pre-admission support in terms of coaching and guidance, and post-admission support also, because this is an entire cycle of enrollment where you picked up a student for an institution and you nurture the student to a good candidate which is going to be passed out. So I taken up on Likert scale of 1 to 5. Then I use the Cronbach Alpha reliability test to check that data is reliable. Then I did, because there is a 24 items, then we did a factor analysis.
Excuse me.
Yeah.
Can you please come on your research contribution part, because we have limited time. No?
Okay, sir. I'm just coming up. So in the Cronbach, yeah. So in the Cronbach Alpha test, like we got a score of reliability test of 0.92. This is my factor analysis, which how I utilized it. Then I used the TOPSIS methodology for the grading. So in the grading, we just found the conclusion that the institution which recently got NEC A++, A+ grade with kind of a proper facilities and the process is the good one in grading of the entire institution. Even the institution, those who are from 10 years, they not come up into that grading system. So this is something how, and this is a limited to a like admission part only, that is the enrollment. So there is a complex framework, which, so this is just a part of to put a lay foundation and look forward for like how the NEC can be improvised more over here. And then I said pick up these of the references, which I utilized during my entire research. Thank you so much, sir. Any questions on it, sir?
So have you done any experiments also so far?
Sir, I just use the questionnaire part for the experimentation, because this is just a one of the paper, one of the part. So then I'm going to work on faculty part and then other parts.
So you have not received any like responses?
Sir, I received the responses. So on which I did.
But you have not shown the report on the responses. Have you shown the reports of the responses? Like what was the responses? What was the outcome?
So the outcome was like the student, I just not recorded on it. I'm having into Excel file. So there the student preferred the institution which having a proper admission process and the support. That is something how it's. So demographic, it's 60% boys and 40% girls. Yeah.
I mean, how can you conclude the research outcome? What is the outcome of this paper?
So the research outcome is like once I use the TOPSIS, so then there I use the data and place it on. So then I get this grading system of the entire out of 8 university, like which university performance, which level.
Okay, fine. Okay, thank you so much.
Thank you, sir.
Okay,
Thank you for
okay.
your great presentation.
What is the ranking mean?
I would like to invite our next presenter, Maria Joyce, and she is presenting on analogizing the role of IoT and data analytics for smart irrigation and aquaculture. Dear author, may please start your presentation.
So shall I start, sir?
Yes, ma'am, you can, please.
Yeah, okay. So good evening, everyone. My paper is all about analyzing the role of IoT and data analytics for smart irrigation and aquaculture. So the abstract of my... So these are the contents which we are going to see today. So the abstract of my project is to develop an IoT-based application where we can monitor and measure the temperature, humidity, and moisture of the soil, and also the temperature for the water, level of the water, and quality of the water. If there's any change in these, the user will be notified. And from these, we are going to collect the data and we are going to generate a report. So these are the few works which we referred, and from this we proposed this methodology. So the main aim is to monitor each and every temperature, humidity, and we are going to detect whether if the measure is incorrect or if there's an increase or a decrease, the user is going to get notified. So these are the sensors which I have used. The first one is DHT11, where it is used to find the temperature and humidity. And the next sensor which I have used is soil moisture to find the moisture level, that is the water content in the moisture. Water content in the soil. And the next sensor is smoke sensor, where we can detect if there's any smoke. And the next sensor is DS18B20, where we can find the temperature level of the water. And the next, I've used ultrasonic sensor to find the water level. And the next, turbidity to find the quality of the water. So the microcontroller which I have used is, first I started with Arduino UNO, and we started it, but we were not able to transfer the data. So the next we moved with Node MCU, where it has an inbuilt Wi-Fi module. So through this, the data were transferred to the database. And the next, we have used LEDs and resistors in our connection. And we have used jumper wires to connect each and every components. And we have used a breadboard for few experimental models connecting the circuits. And we have used a USB cable with it. The database which I have used is Firebase. And I have used Arduino software. And for data visualization, we have used Jupyter. So this is the workflow of our paper. Like, we started with the physical structure where all the sensors and the IoT components were collected, and we connected it. And then from the connected circuit, then we started collecting the data through Wi-Fi, that is the Node MCU. From there, we stored each and every data in the Firebase. And from the Firebase, then we processed data pre-processing, and data visualization was completed. And these are the few more modules. When we come to a farm, we plant, and we also have other cultivation as well. So mainly we focused on this soil moisture, where we have used a DHT11 sensor and soil moisture sensor together, so that we can find the temperature and the humidity of the atmosphere, as well as we will be able to measure the moisture in the soil level. So if there's a decrease or the increase, the farmer or the user will be notified, so that we can rectify accordingly. And so coming to chicken cultivation. So chicken cultivation is like, we have to keep and maintain a temperature for chicken to grow healthy. So for that, we have used DHT11 sensor, and also we have used MQ2, that is the smoke sensor, to find if there's any smoke detected or not, so that it will not affect the chicken's growth. And the next, we have used water temperature. So when, if we are going to go with fish cultivation, we must be sure of the water temperature. So we have used DS18B20 sensor for that. And the next, the water level, if there's going to be a decrease in the water level, we will be notified using this ultrasonic sensor. And the next, we have used turbidity sensor. So we will be able to identify the quality of the water. So each time the quality will be changing, because if it's going to get dirty or any other particles is there, we will be notified through this sensor. So this is how we started. We started with connecting Arduino UNO with any particular one sensor, and we got the output in the Arduino software. And next, we processed with Node MCU, and we got the output in Arduino. Then for the MQ2 sensor, then we started integrating two sensors. And then at last, we got the output in Arduino, and then we stored the data in Firebase. And then this is the connection of DHT11 and soil moisture sensor. And this is the output for the Arduino and Firebase side. And at last, we have connected the first part, where we have connected the soil moisture, DHT11 and smoke sensor together. And the next, the same procedure was followed for this fish cultivation as well, where we started with the Arduino UNO, then we went with Node MCU, Then at last we integrated all the three sensors together, and we got the output in Arduino, as well as we have got the output in Firebase. And from this data, from the collected data, we have performed data pre-processing and data visualization. So this is the few visualizations which we got. The first one is an histogram for the temperature and for the count of it. And the next is the histogram for smoke values. Next, this is the histogram for moisture values. And this is a scatter plot for temperature and humidity, which includes the time as well, at what time we got it. And this includes the date and moisture level with time. And this is the scatter plot for smoke. And this is the histogram for water temperature, scatter plot for water level, bar chart for water level, scatter plot for water quality, bar chart for water quality. And this is a small video references at last, which we did, and we got some outputs. Thank you.
Yeah, it was very nice paper, and I think
Okay.
practically you have done very good. So can you tell me, like, as compared to the existing moisture, moisture sensors, how it is your sensor is doing better?
So we
Have you
had
compared your result with the existing results?
Yes, sir, we have. There's no much difference between the existing sensor and our sensor. This is like when we compare with the price, we can use this project in low cost as well. It gives the most accurate value as the expensive sensor, which gives. There's only one difference is that the soil moisture sensor will have two probes. The normal sensor, the sensor which we have used, has the shortest length, but when comparing to the others, it will have a longer length.
Okay, you told that the price is less.
Yes.
And other than price, what did you say?
Other than price, other than that, whatever that actual sensor is going to give, the results will be given by this sensor as well. Only the length of the probes will be shorter and lengthier.
And what is the level of difference in the prices of the existing sensors and your sensor? If you can quote some example.
For example, 700 to 800.
700 to 800 is the cost of your sensor.
Yes.
Or
No,
what about the existing sensors?
No.
Have
I'm
you
just telling
seen
the
any
difference between these.
Difference is 700. Okay.
Yeah, difference.
So what is the normal cost of a sensor, moisture sensor?
The sensor which I have used.
Which you have used, what is the cost of your sensor?
It's just 175 to 250.
175 to 250 is your price. And the other sensors, you're telling 700 more than your price.
Yeah,
around more than 900 or something. Have you shown those results of the pricing also in your paper?
No, sir. For the
Because
price,
you are telling that the normal sensors rate is 200 and yours is like normal sensor rate is 900 and your sensor rate is 150 to 200. So it's a very big difference, no? 300%. So it's
300% is like, I'll show you, sir, 1 minute.
But yeah, we have to justify those results, no? Because it's giving 300%.
So yeah, there's a two length probes, right? So if the probe size is going to get increased and the high materials are going to be used on it, it's going to be higher. So the sensor which we referred was a little bit higher than this. So we came up with this.
And then what about the quality?
Quality is that you can use this sensor in normal soil as well. It's going to sustain only, but that sensor is made up of other materials, like the steel part is different coming to others. I'm not sure with the material name.
Okay, in your own opinion, what are the limitations still left in the paper?
The still is that we started creating an application that is an Android-based application, so that it will be very easy to be access everything. It is halfway through. If you're going to complete it fully, it will be good.
Okay, fine. Thank you very much.
Okay.
Thank you for your great presentation.
Okay, I got a question. Can you hear me?
Yes, sir.
Can you hear me? Huh? Okay, last question. Did you consider researching Raspberry Pi? Why did you choose Arduino over Raspberry if you did for microcontroller?
Yeah, that's a good question. Actually, what was the reason is that it was a statement which was given to us, using these components, you should find a solution. So using the given components, we went the solution with it. So we were not able to give any suggestions at that time. So we were not able to go with Raspberry, or else we could have gone with Raspberry.
Okay, thank you.
Yeah.
Okay. So moving for our next presenter, Sri Harshini, and she's presenting on discrimination between fake and real emotion using modified CNN model. Presenter, you may please. Yes, ma'am, you are audible. Please start your presentation.
1 second. Good evening to all the panelists present. My name is Shriyashni. I'm here to present discrimination between fake and real emotion using modified CNN model. The authors are Mr. Sunil, Dr. Hari Prasad, Ms. Shrishti, and myself. Yeah, now it's moving.
Yes, it is now.
Okay, I'll start again the introduction. Facial expressions convey very vital information which is useful to interactions. Because of this, it has applications in various fields like human-computer interaction, robotics, psychological studies. Normally, generally, whichever papers, existing papers, or concentration on facial expression identification, like what is the expression, what is the emotion present on the face. What we have done is to distinguish whether the given facial stimulus is genuine or artificial. This can be used for psychological studies or in criminal investigations. And we have done the literature surveys, and we have found that the highest accuracy is 74% with HPM. The technologies and tools used are Jupyter Notebook for coding, Python is the program used, TensorFlow is used for training, NumPy is used for array plotting, Matplotlib is used for image plotting, and OpenCV is used for image detection. The design and development of the process. First step is dataset gathering. Second is facial detection. Third is pre-processing of face images. Fourth is feature extraction. Fifth is validation of BestNet. Sixth is standard model for fake emotion detection. First, in dataset gathering, we have done two types of dataset gathering. One is we have created our own datasets by capturing the images of people around us, and we have manually pre-processed it. The rest was Chalan dataset and fake detection set, which was already pre-processed. Next step is facial detection. Here we have used hair cascade model, that is Weiler-Jonas method, which is used for facial detection of the images. Next, pre-processing of images. First, we have taken RGB images, which is colored images, and we have created into grayscale images so that the pixel quantity is reduced. Then we have done normalizations to reduce the pixel quantity, and to make sure that everything is, the data distribution is very similar, so that when we go for feature extraction, it would be easy. In the process of feature extraction, we have taken the images of eyes, lips, nose, and we have categorized is into fake and real. Fake is 0 and real is 1. Next, we have gone for our classification model. Here we have used CNN classification. The reason we have used CNN classification is we have 123 feature extraction. As CNN network has very many layers, we will be able to extract these many features easily. And CNN layer has 7 layers. First is input layer, where we give the images in input. Convolution layer, where the input images is filtered across the layers horizontally and vertically to convolute the layer. Next is ReLU layer. Here, all the negative values are converted into 0 to make a threshold function. Next is max pooling layer. This layer is done to minimize the complexity of function. It reduces the dimensionality of function. For example, let us take 4x4 grid, which is converted into 2x2 grid. Next is batch normalization, where we normalize all the images, then dropout layer. If we come to CNN layers, there are many layers. So some of the layers are ignored. So we activate these layers to get the output. Next, we go for the classifier, which we have used softmax classifier. We have used 80% for training data and 20% for testing data. And we have used 4 various nets named as LeanNet, AlexNet, ResNet, and VGGNet. These are the data set which we have manually gathered and pre-processed for testing and training. And these are the results obtained. For ReNet, we have 2 convolution layers. We have done 50 epoch. It is due to the limitation of our laptops, which is CPU based, not GPU based. We have got training accuracy of 58%, test accuracy of 58%, and train accuracy of 50%. And AlexNet, which has 5 layers and epochs of 50, we have got test accuracy of 69% and train accuracy of 70%. Then we did ResNet, which has 13 layers, which 86% of test accuracy and train accuracy of 95%. Then we did VGGNet with 10 epochs. Due to the limitation of our laptops, we got test accuracy of 81% and train accuracy of 80%. From the above observation, we can conclude that ResNet has the highest yield. So we took this model for our developed model. This is our developed model. Here we got the accuracy of training data of 96% and model test accuracy at 98%. The result which we have obtained is because we have used 16 convolution layers of ResNet. We have ordered dropout layers, so we have got this much high accuracy. And the conclusion is we can use these models to cure depression, mental disorders. It helps in understanding the people better. And this can be used in computerized process for facial emotion recognition. And the accuracy is comparably higher than other models. On future scope, we can use this model for real-time capturing of images, and we can use signals from brain and heart for pre-processing. These are the references we have used, and thank you.
Yeah, am I audible?
Yeah.
Can you come on the slide number 12?
Okay, 1 second, sir. One second.
Yeah, on slide number 12.
Yeah. Yes, sir.
Here in this RES net, the test accuracy is 86% and the train accuracy is 95%.
Yes,
So
sir.
can you justify the reason behind that?
Which AlexNet, sir?
No, this RES NET.
ResNet has more convolution layers, sir, which first presently we have used 13 layers in this process. Whichever result I have shown right now, we have used 13 layers and 100 epochs. And the data set is very huge. That's why we got these much result.
Okay. So in this LENet, it is the test is 58% and train is 50%.
Because the convolution layer is only 2 layers is present, sir.
Okay. Okay, fine. Thank you.
Thank you, sir.
Okay, so moving for our next presentation.
Okay. Thank you.
Our next presenter is Darren Lemkin, and he's presenting on improving attitudes of underrepresented high school students towards STEM, virtual summer program. Dear presenter, you may please start your presentation.
Can you all hear me?
Yes, sir, you are audible.
Okay, can you see my screen?
Yes, sir.
Okay, all right, as you previously mentioned, I want to discuss how we discovered and measured attitudes doing virtual training using machine learning. And so I work with Jackson State University, and then I attend Oklahoma State University as a PhD candidate. So again, my name is Darren Lampkin, and I'm going to talk to you about how we measured student attitude towards STEM. So the background here is STEM in America, we're still underperforming and not producing enough students to meet the demand. So we're trying to figure out creative ways to increase the supply. And so one approach here is to do more hands-on learning and more creativity. And so we want to build that interest for those traditionally underrepresented in STEM. So specifically Black, Latino, Native American, etc. And so we use what's called near to peer to near peer mentoring, which is basically the high schoolers mentoring one another. And those that truly understand programming and coding, those were identified as the peers, and those were in past activities and past summer camps, they served as the mentors as well. And so that's the introduction there. And as we did a literature review, we learned that students need to be able to connect and relate to the projects and be able to make meaning of it. And near the peer mentoring is effectively increasing interest in STEM for both mentors and mentees. So we know that we had a great model there when it came to relatability. And it's important to allow them the flexibility to fail and learn on their own. And so that's why autonomy is very critical when it comes to the research design. And it helps with developing the competencies and again, the relatability. So the problem, again, as I stated, was we have a shortage with STEM professionals. And so instead of focusing on collegiate students, we wanted to focus on high school students, those traditionally underrepresented in STEM. So these are the research questions. And with the research questions, we decided to look at 3 constructs, which is interest, perceived ability, and values. And we wanted to see if there was a positive change after they learned how to do coding through machine learning. So again, these are our hypotheses. Will there be a change or no change when we do the activities with them? So our design consisted of a pilot study, and what we used was the Mark Mahoney attitude towards STEM questionnaire. And we took that paper-based questionnaire and made it online using this platform called Qualtrics. And our scale was disagree, I do not know, and agree. And it was initially a 5 Likert scale, but we reduced it to 3 to help students make more direct decisions. So the participants consisted of 17 high school students selected from 9th through 12th grade students in Jackson Public Schools. And we utilized what's called the Junior Reserve Officer Training Corps, also known as the JRTC program, to participate in the Summer Institute. So here's the breakdown of the students. You know, you had 17 participants and 5 mentors. Again, the mentors consisted of individuals that participate in the past, and then the peer to near peer model, those were those that emerged and truly were identified by amongst the peers. And we did reward-based learning, where each team competed each week through each project. And so week 1, they focused on teamwork and getting to know each other and doing icebreakers to build the rapport with one another. Week 2 was focused on artificial intelligence with MIT App Inventor. And we did pre-surveys for the attitude towards STEM to Mark Mahoney. And then week 3 was building a portfolio website with Bootstrap. And then week 4 was the STEM application in medicine, specifically drug discovery, natural compounds, and we just compared that. And then we did a post surveys for the attitude towards STEM. At the end of each week, the students team delivered the products related to each activity concept. So here's the results. And as you can see, we had to scale it. And when we did a count and percentage results, we learned that when there was an increase, some of the questions pointed in different directions. So we had to reverse code to make the design make sense. But there still was a change in the attitudes. And so let me specifically discuss how each question is broke down. And so the pre-test versus post-test when it comes to the construct of interest, this is per question. And what stands out the most is number 6, how STEM is appealing, cool to me. And initially they disagreed, and then they increased the amount of agreements. And so, well, in addition to that, I like STEM. And we also measure, I do not like learning STEM. So some of the scales were in a negative format. So that's why it was important to do a reverse coding. The percentage again for value, there was a true impact when it comes to the learning. Specifically, is it valuable? And we noticed that they discussed values that are different. So the values were truly defined so uniquely amongst each one, but that was still an increase from value from 88 to 94. And for perceived ability, this is whether or not they believe they can conduct a future degree within STEM. And so this construct was the one that I desired to improve the most, because we wanted to impact the STEM is difficult to me for those that were so afraid of STEM because of the concept of STEM. Math is too hard. We wanted them just to consider it as a possibility. And so, as you can see with the pretest, they disagreed, and then it changed to STEM and difficult to me. So it was an increase from the 58.
Sorry to interrupt you, sir. Do you have last 1 minute?
Okay, all right, thank you. And here's the analysis here. And as you can know, we were able to reject the null hypothesis as less than a critical value for a two-tailed test. And we did a ranking test, which showed an impact for interest and value and perceived ability. And here's our conclusion. Participants acquired new knowledge of STEM terms. Students used practical examples describing STEM. There was a positive change in the value, and they learned how to use MIT App Inventor. And here's some of their projects right here. They created websites, learned cuisines, did identifiers, and specifically using different hair types. And these is pretty much all the different projects that they were able to do with the natural compounds and the different websites. So that's all I have. Thank you guys for your time.
Yeah, first of all, I'd like to say that your PPT is very beautiful. It's having good colors. So it's a very nice thing. So I think your work is seems very nice, and I don't have any questions specific. If anybody else wants to ask.
Thank you for that. I really appreciate that.
Yeah, it's a very beautifully designed PPT. Very nice.
Thank you. I can't hear you. I can't hear you. I see your mouth moving.
Okay, sorry. There's no questions, so we are moving forward for our next presenter. Our next presenter is Shakshi Kinha, and she is presenting on machine learning model for the email spam detection with data mining techniques. Dear presenter, you may please start your presentation.
Hello, am I audible?
Yes, ma'am, you are audible.
Okay. Hello,
Yes, ma'am.
is it visible?
Yes, it is visible. Please make it full screen and start your presentation.
Sure. Okay. So, hello everyone. My topic is machine learning model for the email spam detection with data mining techniques. So, the contents are introduction, literature review, research gap, problem formulation, objectives, steps of spam mail detection, methodology, result, conclusion, and then references. So, the first one is introduction. So, machine learning is the investigation of PC calculation that can learn and create all alone with experience and information. And email has become an essential mean of communication due to high efficiency and comfort it offers, like it uses in offices and various eh, educational sector and various sections. But the number of spam is on the rise because the spammers can make huge profits with a small expense by spreading advertisements or other hateful news to users' mailbox. And then some offenders also send computer viruses along with the emails, resulting in a great threat to the computer. Spam, commonly thought of as an unwanted bulk email or redundant commercial email, has affected our normal communication by email in a very bad way. Email customers get several hundred spams on regular basis with a fresh content from fresh addresses which are robotically produced by robot programming tools. The traditional methods named need dark whitelist are ineffective to filter the spam. So the text mining methods are implemented to an email for maximizing the yield, the filtering of email spam. In this email spam detection technique, there are various phases such as to pre-process the data, extract the attributes, and classify the data. So these are the literature review. So the latest one is from 2020. And the research gap. In the past year, several prediction algorithms have been developed for spam mail prediction based on the supervised machine learning algorithm. But in the previous developed methodology, the problem is turned out to be less accuracy. In this research work, the main focus is to develop a good assembled classifier for better accuracy of model. So the problem formulation. Problem formulation was the detecting email spam is a challenging task. As the survey demonstrates, most authors use Twitter's dataset to detect email spam. But the big problem with such dataset is the tweets contain limited number of words that don't convey the exact meaning sometimes. People face many issues while expressing their reviews by various means. So like if we know today's this sarcastic way, we don't know the exact meaning of the way there is different views. So to rectify this, there is a need to apply a technology that can analyze email spam detection algo along with the classification. So the objective was to review and examine many machine learning algorithms to detect email spam detection. To second is to apply standard machine learning algorithms to detect spam email. Third is to classify machine learning algorithms using data sets. Fourth is to make comparison between existing and proposed methodology based on performances in the context of various matrices, such as recall, accuracy, precision. So the steps of spam email detection was the first we start, then we extract data from the Google using Google API. After that, we extract features of the data and make relationship between attributes and target set. Then we apply multiple classifier for the training set. Then apply 3 algorithms, naive Bayes, random forest classifier, and support vector classifier. Then we prepare training sets for the classification. After that, we apply voting classifier and test classifier. Then we generate the predicted result. But in this, like there are various phases. In the pre-processing stage, the majority of real-time data are partial comprising, combined, noisy, and missing values. Pre-processing is a significant data mining step for preparing the data set prior to the mining processing. The main objective of this step is to remove few words such as combination words, articles from email structure on the grounds that these words have no significance in classification. And some other words of this type includes like stop words or punctuation. And like in general, we use such as word is, the, a. So the support of these words is negligible in identifying spam feedbacks. So that's why for better accuracy, we removed prior to tokenization to prevent noise and redundant tokens. Then part of speech tagging. In this, it mostly includes tagging words features with parts of speech according to the identified context of review text. And in the basic type of POS, tagging is identifying word as nouns, verbs, adjectives, adverbs, and so forth. Then there is semantic feature selection. In this, the phase emphasizes on selecting a subset of attributes to reduce the data size. This process minimizes a specific cost function. And the contrary to feature extraction, feature selection does not change the data and applied at the data preprocessing stage prior to the training of a classifier model. This procedure is, we can generally say, as variable selection, feature reduction, or variable subset selection. Then there is feature selection, feature extraction. Feature extraction techniques are concerned with transforming available features into a novel feature space of reduced size. This process generates new features on the basis of linear or nonlinear mixtures of features from the real-time data set. Then there is email classification. So classifying an email message comes under supervised learning task. It's is generally to construct a probabilistic algorithm of a function for mapping emails to classes. The supervised learning of text in email messages in which a whole dataset is utilized to illustrate a single instance of messages for classification. Presents a learning model with a set of patterns whose pre-classification or labeling is done. This set is known as the training set, and the multiple classified messages from the training sets are eliminated from the construction of model to be applied for testing its efficiency level. This set is known as the testing set. And various techniques are constructed from diverse sections of these instances to train and test the system for measuring the accuracy of the built model. This cycle is known as N times cross validation. In this, N represents the number of times the instance set is divided. And in this, the number of instances we used is 5,174. And number of training samples I have used is 2,194, and number of test samples are 727. So in this result, the previous models was the for a SVM 76.89%, precision is 78.90%, and recall 76%. For KNN model, its accuracy was 74.56%, precision it was 74%, recall 74%, 80.2%. For random forest, it was 80.12%. Precision, it was 80%. Recall, it was 80%. But in the proposed model, it was accuracy is 90.12%, precision is 91%, and recall is 91%. So the graph of the proposed model, accuracy of proposed model, and the accuracy is 90.12%, and precision and recall is 91%. So the conclusion is of this paper is the com- complex task of machine learning is to predict the email spam. In previous year, several methods are developed to detect email spam on the basis of tokenization, word polarity, etc. But this work proposed a machine learning technique for the email spam detection, which is based on the various phase. This phase and these all the results is up to 90%, 91%, and 91% respectively to the precision, recall, accuracy. So here are the references. So thank you. Any questions?
I think the precisions and the recall, whatever you are telling, the difference, it is almost 10% increased.
Yes, sir.
So yeah, at the one part, it's a good results are good, but can you
Yes, sir.
justify how it is like directly 10%? Well, 80 to 80, like if it is 80%, then 81, 82, 83, we can understand. Now
So,
it's going to 90%.
previously it was like we are using emails for the samples are like that was there are various words that are punctuation words, stop words. So it was so hard to calculate its accuracy and other things. But in this proposed model, we removed such words prior to the testing. That's why.
And have
Because
you also
nowadays,
like have you also modified data set?
yes, sir. Yes,
Data
sir,
set
we
is same or you have changed the data set?
changed the data set.
Okay, okay. And what about other parameters? Sometimes when we change the data set, then other parameters also affect the results.
But sir, that thing is taken care about by my other authors, that my seniors. So
Okay.
there was not such issues because we
Because you know,
done it by.
in any research, whenever there are some results and there is big
Y-
difference in the results, so there
Yes,
must
sir.
be some overheads associated with that. So can you justify about those overheads?
Pardon, sir. About
Like
like the parameters what they have taken and the parameters what I have taken.
yes, yes, yes. Any overheads? Any overheads?
No, sir, not as such issues because there were mostly these data sets were the similars, not exactly the same, but they were the similars.
Fine. But whenever you are modifying or updating some existing methods, na, there
Yes,
must
sir.
be some overheads or some extra things which are coming with the results. So just try to observe those things also and try to include in the next paper.
Okay, sure,
Okay.
sure, I will do that.
Okay, fine. Thank you
Thank
so
you,
much.
sir.
Okay, thank you for your great presentation, ma'am. And now we have all completed all the presentation, and I sincerely thank our authors for their excellent presentation and great contribution, and all the participants for being a part of this international conference. I hope the session was informative enough, and we on behalf of whole team, thank you for your support during this version and the previous 6 version of this conference, and we will be happy to have you all in the 8th version of this conference in 2023. Moreover, all the participants will be getting their digital certificates through email within 2 working days. And further, all the papers have been already forwarded to the Springer. And the publication will be live within 5 to 6 months, so kindly cooperate with the team ICTCS 2022. Now, I also thank our session chair, Dr. Vijay Singh Rathore, to chair the session. Thank you very much, sir.
Thank you so much for the appreciation. Thank you so much.
Okay, thank you for your presence. Okay. Now in the end, I would like to request you all to turn on your camera to catch up some great memories of this virtual conference. Thank you, everyone. Thank you, sir, once again.
So I congratulate all of you for presenting your papers such a nice way and wish you all the best.
Thank you
See
so
you
much,
soon.
sir.
Next time
Thank
in the
you so
physical
much.
conference.
Thank you so much,
Thank
sir.
you.
Bye bye. Take care.
Bye-bye.
Thank you. Everyone stay safe and take care. Bye-bye.
Thank you, Archie.